Yeah. So today I'm planning to cover the lectures that were there in week 8 and week 9 together. So these are about graphical models. Now this particular branch, this particular topic is not used that much today, except in certain very few niche applications. I'll just go through them and I'll try to cover some 12 questions from both undirected and directed graphical models. So, and towards the end I will have if you have any questions in between, you can stop me and ask. So I'll start with this. Okay, so the first question is the figure shows below a Bayesian network with 9 variables. So there are 9 variables and all of which are binary, and you have been asked to say that which of the following is or always true for the above Bayesian network. So let's go over them one by one. So the first question is P of A comma B given G is so A and B are conditionally independent given G. So that is what has been given. So G is here and A and B are here. So if G has been given to you, then that doesn't, of course, A and B can have, because B affects G through both C and E, and C and E affect D and F respectively, which finally go and affect G. So therefore just because you know G doesn't mean A and B will become independent. So there will still be some dependence due to this all these different nodes, and therefore the first option is not correct. The second option is P of A comma I equal to P of A and P of I. So that effectively means that okay, everything changed for some reason. Great. So that means that this particular node and this particular node are the independent of each other. So if you see, A affects C, A affects D, and D affects G, and G is not directly affecting I. So whatever value I will take is not affected by the value that A is taking, and therefore A and I are indeed independent. So whatever value A will take, suppose these are all binary variables, so A can take 0 or 1, but that doesn't play any role in what I is, and therefore P of A and I are independent random variables, and therefore this option is correct. Okay, then comes B comma H given E comma G, which means again that is you have been asked to say whether they are independent of each other. So E comma G is given. So let's say this is given to you and this is given to you, these two are given to you, and does that mean that B and H are independent of each other? Again, that doesn't, of course from the graph you can see that there is if E and G is given, then maybe F, you can think of F as being something, you can think of F as becoming as known, because F is directly affected by E. But E and G being given to you doesn't mean that this itself is becoming independent of this, because B is also affecting C, C is affecting D, and D is affecting G. So B and G are still in some way related in some way, and therefore just by the knowledge of E you cannot separate out B and H, correct? Therefore B and H cannot be independent of each other because of, even when you know E and G. And the final is P of C given B comma F. So now what is given to you? B and F, these two are given to you, which means that this is given to you and this is given to you. Now when B and F are given to you and you are asking somebody to tell you whether P of C given B comma F is equal to P of C given F, which means that if you have the knowledge of F, then the knowledge of B doesn't matter to you. That is what this particular statement is claiming, and of course that is not true, right? Because I mean it's pretty obvious that C can depend on C is directly dependent on B, and therefore it is obviously not it is not true that just because you know B and F, just because C will just because you know F, you will be able to find out the probability distribution of C is not a correct statement. So therefore in this case only the second option is correct, that A and I, since they are not connected by in any way in this graph, in this directed graph, P of A and P of I will factor out into P of A comma I will factor out as P of A into P of I, as they're independent of each other. Okay, then comes the next question. So consider the following data for 20 budget phones, 30 mid-range phones and 20 high-end phones. This is H, high-end phones, so these are 20, 30 and 20, and these are the different configurations, whether it has a single SIM slot, it has a 5G compatibility, and some NFC. I don't know what NFC is, but anyway, so some NFC is there. So these are the three features that you have: single SIM, 5G compatibility and NFC. And you have to calculate the probability of this phone being a budget phone, a mid-range phone and a high-end phone using the naive Bayes method. So the naive Bayes method says that given a particular class, so if you have a particular class, let's say the class probability is PC, and the three features in this case are x1, x2 and x3, then given the class, x1, x2, x3 are independent of each other, are conditionally independent of each other, right? So so basically your answer would be this. I mean the correct ordering of, I mean the probability of calculate the probabilities of this phone being a budget phone. So of you put one by one, you put the classes in here and the features you already know. So these are x1, x2, x3, and you will calculate the probability in that order, and you have to find out the probability of these features occurring for a budget phone, mid-range phone and a high-end phone, right? So let's calculate one by one. So consider a phone with 2 SIM card slots and NFC and no 5G compatibility. Okay, so SIM card slots I'll denote by S, the 5G compatibility I'll denote by G, and the NFC I will denote by N. So these are your three features, and your classes are B, M and H. So let's calculate the probability of this being a budget phone. So the budget phone, by the naive Bayes method, it would be given these features. So let me write it a better way. Okay, given these features, so what are the features? You don't have S because this is single SIM and you have a 2 SIM card slots. Okay, you don't have 5G compatibility, but you have NFC, right? So this is the probability that you need to find out. So going by the naive Bayes formula, this would be equal to probability of the class being budget in this case. So what is so out of 70 phones you have 20 budget phones, so this would be 20 by 70. Then P of x1 is x1, so that means for budget phones you have single SIM cards in 15 out of the 20 cases, but here you have the NOT operation over S, and therefore this would be 5 by 20. Then you don't have 5G compatibility, so that would be 15 by 20. And finally you have x3, so none of the phones have x, so this would be 0 by 20, so this would turn out to be 0. Okay, similarly if you do this for the mid-range phones, let's say, So mid-range phones, it would be 30 by 7. Okay, I don't know what is happening. Yeah, 30 by 70, because you have 30 mid-range phones out of 70. You don't have a single slot of SIM, so that means it would be 10 by 30. You don't have 5G compatibility, so that is also 10 by 30, and you have NFC, so that is 15 by 30. So this calculation, this 30 and this 30 is cancelling, and this is half. Okay, and this would be okay. Let's do the other, and let's finally let me try to do something. This is for the high-end phones. So high-end phones also, it would be 30 by 70, 20 by 70, sorry. This would be 20 by 70. Then x1 given C is 15, which is okay, 5 by 20. Then 5G compatibility is, you don't have 5G compatibility, so that means this is also 5 by 20, and NFC is 15 by 20. So I guess it would be the correct ordering. I'm not sure whether this calculation I mean, I will not do it, but looking at this, I feel that it is budget should be lowest because it has 0. Then it should high end, because I feel that the this one is less than the top one, middle one. Therefore it would be either, it would be budget, high end, and mid range. But these calculations you can do and check for yourself, but I guess it would be option B, that budget would be the lowest, then high end, then mid range. These are the 3 probabilities. I mean, this is the correct ordering of the phone type from the highest to the lowest, highest to the lowest. Okay, so highest to the lowest should be mid range, high range, and budget. So highest probability is mid range, then high end, finally budget, right? Okay, so the third question is, which among gradient boosting and AdaBoost is less susceptible to outliers considering their respective loss functions? So if you go through the lecture, it's clear that gradient boosting uses a mean squared loss, and AdaBoost uses a exponential loss. And exponential loss, if you move away, so outlier means it is very far from your other examples, and therefore AdaBoost will be more susceptible to the outliers because it will give an exponential loss to that, while gradient boosting will only give a MSE loss, and therefore gradient boost is less susceptible to outliers considering the respective loss functions. Then how do you prevent overfitting in random forest models? First is increasing tree depth. Of course, if you increase your tree depth, that means you are learning your training data much better than normal, and therefore this obviously won't be the correct answer. Increasing the number of variables sampled at each split is will again lead to overfitting, because the lesser number of variables that you are using at each splitting point, the more the reduction in variance is more, and therefore increasing the number of variables sampled at each split will obviously not lead to reduction of overfitting. Increasing the number of trees would lead to increase in the variance reduction. If you have gone through the lecture, it is clear, the instructor has also told that if the number of trees increases, then your variance reduces, and variance reduction is nothing but reduction of overfitting, and therefore the answer for this would be increasing the number of trees. Again, ensembling in a random forest classifier helps in achieving. Of course, this is like this is something that should come to very naturally whenever, this is not only true for random forest but any classifiers. If you design any classifiers, and if you take multiple of them and take an average of their predictions, then you would generalize much better to the test data, and it would lead to the reduction in variance error. Okay, so that completes the this thing about directed graphical models. So the next part is about undirected graphical model. So in the undirected graph below, which nodes are conditionally independent of each other? So this is pretty easy to see, like the rule for this is quite simple, like you just look at the two nodes, you just look at the two nodes which are your candidate nodes and see whether the node that has been given to you is the only path that connects that node to the other, right? So that is the only thing that you need to look at. So for example, if you have so let's say you have been given B, so B has been given to you and conditionally independent of each other given B, which means that conditionally independent given B, which means that B should be all the paths that go from A to D should only pass through B, so that once B is given to you, A and D become conditionally independent of each other. And so let's see if A and D, so A and D, if you see, A and D has a path like this, A and D has a path like this, and that doesn't concern B anywhere. So A and D cannot be conditionally independent of each other when you have been given B. Similarly, D and E are directly connected to each other, so they can't be conditionally independent even if you know B, doesn't matter. C and D, again the same path that goes through E, you have that, and therefore C and D cannot be conditionally independent of each other given B. And A and F, of course B doesn't play any role here, so none of the above is the correct answer in this case. None of the nodes are conditionally independent of each other even if you have B. Now this graph changes and becomes like this, and now we have to answer the question that given B, again you have been given B here, what is the conditional, what is the, are any of these variables, any of the options now conditionally independent of each other, given that you have to consider that you have been given B. So C and D, so you see C and D has only one path that passes through B, and you already know B, therefore C and D become independent of each other. So C and D is the correct option. D and E again is connected directly, so D and E cannot be the correct option. E and C only passes through B, and therefore E and C is also another correct option, and A and F has no B in between, so A and F cannot be the correct option. So C and D and E and C are the correct options. Okay. So in the undirected graph given below, how many terms will be there in its potential functions? So potential functions, if you I think a very similar example was given in the class also, like so if you have a clique, which means a connected group of nodes, where so maximal clique means, so for example in this case you can have this as one clique, this as another clique, and this as another clique. You have covered all the nodes, and whatever, so if this is clique 1, if this is clique 2, and if this is clique 3, then that you see that all these nodes are connected, they form a loop within themselves. And so how many terms will be there in its potential function? So that will be equal to the maximum number of maximal cliques that you have in this particular graph, and therefore the answer is 3. Of course, once you find the number of cliques to be 3, you know that that would be the answer, because you have the maximal number of cliques, and that should be, if you have 3 maximal cliques, then that should be the minimum number of terms that you have in the potential function factorization.
Excuse me?
Yeah.
As you said, that clique should not have a loop.
Yeah.
So
No. Clique should have a loop. That's what I'm saying.
So why we cannot consider A, D, C, F, B, all the 6 nodes as a clique, as all of them are connected?
Okay, so let me just give me a minute. I did not expect this question. Okay, just give me a minute. Maybe I'll show something to just give me a minute. Hello.
Yes.
Yeah, so one property of cliques would be, I forgot to mention that. So people from computer science, if they are here, they can probably correct me. So the one property that cliques have is all the nodes that are there in the clique need to be adjacent to each other. Okay, so if you are taking this particular clique which you just said, like if this is the clique that
Okay, then yeah.
you have said, right, then you see E and B, they are not adjacent to each other. Okay, so all of them should have one edge between each other, and yeah, so that is the definition of clique basically.
Yes, yes. Thank you.
Yeah, so sorry, I actually I don't know if there are computer science people. If there are, if I said something wrong, you can correct me, but I think that is the definition for clique. Okay. Okay.
I have one doubt then in that.
Yeah.
Maybe I'm wrong,
Huh.
but then can you just scroll up with the image?
Huh.
But in this case, then A and C are also not adjacent to each other.
No, A and C are
This is
adjacent
the
because of this.
Okay, that edge.
Yeah, that edge. Edge, I mean adjacent means there will be a direct edge connecting the two nodes.
Okay, so edge should be there between them.
Edge should be there
Even
between
if
them.
they are placed somewhere, but the edge should
Edge
be
should be there. Yeah.
there. Okay, thank you so much.
Yeah. Okay. So then which of this is a application question, like which of these can be modeled as a HMM. Select all that apply. So HMM can be used in any such case where there is a sequence to sequence learning model. So for example, what can I say? So sequence to sequence learning model means, for example, you have something like a sentence, let's say, or not even a sentence. Let's say I'm talking right now. So this is the speech. These are the speech. So how are you? So this is something that I am speaking right now, and this is something that you have observed. I mean, of course, you understand the speech. I mean, you hear the speech that you hear what I am saying, and these are the three words that I have said, and you observe these three words, and you try to find out I mean, when I am speaking, basically what in speech recognition, what happens is, I am saying how, but this how is actually broken down into certain units called phonemes. Okay, so these are the basic units that I am basically pronouncing, and because of this specific way in which I am producing a set of phonemes, I am actually pronouncing the word how. So these phonemes are actually getting pronounced in the back end, if I may call that, and that is giving rise to some particular words. So whenever you have these sort of a thing, that there is some sequence learning which is going on, some way in which I am producing a sequence, you can use HMM to model that. And if you see machine translation and speech recognition, these are the two recognition or the sequence learning tasks that we can model using HMM. Fibonacci sequence modeling as a HMM, there is nothing hidden in there. You know how to create a Fibonacci sequence. And trajectory of a baseball is again, it's a time series sort of a thing, but trajectory of a baseball can be a physical event, so it is not essentially some hidden things which are influencing the trajectory of your baseball. But generally machine learning, this machine translation and speech recognition, it is still being used, I think. Machine translation, HMMs are not used anymore. Speech recognition also, HMMs are stopped. I mean, HMMs are slowly going away, but these are the two famous applications of HMM that we have. Okay, so the final question is, for the given graphical model, what is the optimal variable elimination order in trying to calculate P of E equal to E? So P of E equal to E is basically the marginal distribution, I mean the joint distribution marginalized over D, C, B, A, and this is A, B, C, D, E, right? So these are your marginal distributions, and I mean this is the joint distribution, and you marginalize over all the other variables and you get a P of E equal to E. So you see here what happens is D directly affects E, but D is dependent on C, B and A. Whatever values A will take, it will start affecting B, B will start affecting C, and C will start affecting D. And therefore if you start with eliminating D, then what will happen is you will have to marginalize over all the values of B, all the values of A, B as well as C, because you have to eliminate D first, right? So that becomes that of course that should not be the right way. You should not have to, just to eliminate one variable, you need not marginalize over three other variables. And therefore the first option is, of course, if you have A, you see that A doesn't depend on anybody. So so A doesn't depend on anybody, so that should give you a clue that you should start eliminating with A. So let's just do this. So let me again write it in this way. So P of A, B, C, D, E. Now A can be written like this. Now once A is fixed, you know how to fix B. Once B is fixed, you know how to fix C. And once C is fixed, you know how to fix D. Once D is fixed, you know how to fix you know how to fix E, and this is what you want. So basically what you can do is you can go ahead and first sorry I have written the exact same thing as in this sum. It's just that whenever I am marginalizing, I mean I have to sum over A, B, C and D. So whenever A is the conditioning argument, I have moved that sum here. Whenever B is the conditioning argument, I have moved that sum here. I don't need to marginalize over A here because I have already marginalized A in the first sum, right? And therefore A need not be marginalized here. And so in this way, if you do, then the first elimination, so here what you are seeing is, this is of course the optimal elimination. Why? Because everywhere in all these conditional sums, you will just have a table. For example, P of C given B would be, suppose B is a binary variable, so B is taking a value of 0 and 1 and C is also taking a value of 0 and 1. So you will just need to calculate these different entries. So all these different entries I finally probably will be learned for your application, but you just have to calculate these 4 entries, and therefore this A, B, C, D, first you eliminate A, then you eliminate B, then you eliminate C, finally you eliminate D to get your answer of P of E equal to E. So this, I mean, this is a quite complicated way of looking at it, just remember that whenever you are given such a model, graphical model, you start with the variable which is not dependent on anybody else. So A in this case was not dependent on anybody else, and then go on in this way. Now once A is given to you, of course you don't have to think about C, D to calculate the value of B, because B only depends on A. Therefore B should be the next variable that you need to eliminate, and so on. So this is once the graph is in this way, you don't need to go through all these calculations. You just look at the graph and you would understand that how you should start eliminating variables. Okay, so yeah, so that is the end of this. So any questions? Yeah.
I have a doubt.
Yeah.
This time in assignment 8.
Right.
Question number 4. Assignment 8. This time.
Just a minute. I'll open that. Assignment 8, right? I said.
Yes.
Yeah. Assignment. Yeah. Which question?
Question number 4.
Okay.
Number of parameters in naive Bayes model.
Consider the problem of learning a function x where y is boolean. So okay, and x is an input vector x1 x2 where x1 is categorical and takes 3 values, and x2 is a continuous variable normally distributed. What would be the minimum number of parameters required to define a naive Bayes model for this function? Okay. Yes, what would be the minimum number of parameters, and where x1 is categorical and yeah, so what is your doubt in this? Hello.
Hello.
Yeah.
Actually, I could not understand how the parameters are equal to 9. How the answer is figured out. I couldn't understand.
Okay, let me think of this. Okay. See, x1 is categorical, right, and it takes 3 values, which means that okay, so for it. Yeah, so let me write it down here.
In that sum, should the answer be 8 actually?
Let me try to see.
2 to the power 3 is 8.
Yeah, so
I don't know how 9 came because of that.
So let's say x1 has 3 values, right? X1 is categorical, so x1 takes 3 values, and x2 is said to be continuous, right? I'm not looking at the question, so if I'm mistaken, please let me know. So this is normal distribution, right? This is what is given in the question as y is boolean, correct?
Yes, correct.
Okay, so y takes 2 values, that is for sure, x takes 3 values. So okay, so what you need to do is, see, y, let's say y takes 0 and y equal to 1. So so for the prior, so if you remember naive Bayes, what was this? This was the class probability. This was the given the class probability, what is the this makes sense? Whoever Prajakta, you asked the question, so this makes sense, right?
Yes.
Right. So see here, okay, so these can take two values here because y is 0 and y is 1, so these can take two values, but you only need one value for the problem. Why? Because p of y equal to 0 plus p of y equal to 1 would be equal to 1, correct? Because there is a probability distribution. So you only require one parameter for predicting for this class information. Okay. Similarly, for let's say now p of x1 given y equal to 0, p of x2 given y equal to 0, and p of x3 given y equal to 0. So again, if you have three features, out of these three features you only need the value of 2, because this will again sum up to 1, correct? Is this clear?
Yes.
So you require any two of these. So let's think you know the first two. The last one you can derive by subtracting 1 minus this. So for y equal to 0 you have two parameters. Similarly for y equal to 1 you will have two further parameters, correct?
Yes.
So till now you have 4 plus 1. So is this okay till now?
Yes.
Now for this, for the continuous variable, for normal distribution, all you will need is the mu and the sigma. The mu being the mean and the sigma being the standard standard deviation or the variance, whatever.
Okay.
So for each x2 you will require mu and sigma, and that you would require for both of the classes. I mean, you would require mu sigma given y equal to 0, and you will require mu sigma given y equal to 1, correct? Because these are continuous variables. Is this clear?
Yes.
So mu and sigma means you have two parameters, and for y equal to 0 and y equal to 1 you have two more parameters. So in total you have 9 parameters.
Yes. Thank you.
Okay. Okay, so any more questions?
Yes. Actually, question number 7 in the same assignment. Question number 7.
Okay, just give me a minute. Question number 7. Oh, I closed that. Okay, this is a graph question, is it? Somehow that is not coming. Okay, let me see. Consider the following graphical model: A, B, C, E, D. Okay. Right. Now consider the following graphical model. Which of the following are false about the model? A is independent of B. A is independent of B when C is known. A is independent of B when C is known. No, this can't be true, right? Because D is there. So you don't have the entire information about B only with C. You need to have the information of D as well. I mean, your parents can be, the nodes at this level can be independent of each other. Only you have the knowledge of both C and D, but you don't have the knowledge of D, and therefore the A and B cannot be independent of each other even when you know C. Okay. Second one is D is independent of A when C is known. D is independent of A when C is known. C, once you know, when C is known, okay, C is known, right? Yeah, C is known to you. Once C is known to you, but D you don't know. D is independent of A when C is known. Okay. D is independent of A when C is known. You know C. That doesn't mean D becomes independent of, let's say, B. And D is not independent of B. Yeah, I mean the second option is, D is independent of A when C is known. Of course, C you know, right? Hello?
Hello.
Yeah. Any questions?
That means this second option is true. It is not false.
No, D is independent of A when C is known.
It is true.
D is independent of A when A is known. Let me think once more. It has been given as false, right?
Yes, it is given as false, but actually it is true because C is the parent of D.
C is the parent of D, and B is also the parent of D.
But B
is also the parent of D. So once you know C, that doesn't make D independent of B. That doesn't make D independent of B, and if you know C,
actually if we know C, then the probability of D will be completely derived from C because it will be dependent on C only.
No, it is dependent on B also, no?
No, it is not dependent. Yes.
It is dependent on B also.
Yes.
So if it is dependent on B, then that doesn't mean that whenever you know C, you will completely know D.
Okay.
So that is why this it will not be independent of B, and hence it will not be independent of C, because once you can't establish the independence of D and B, then of course B and A being at the same level and affecting C, you will not find A will also start affecting C. You can think of this in this way, like C depends on A and B, right?
Yes.
And D depends on C and B. I am talking about direct dependence here.
Okay.
I am talking about direct dependence here. And indirect dependence, if I talk about, then it is also dependent on A, because A is affecting C.
Yes.
Now, in this case, you just know C. This is the only thing that you know. But B is still there. And B being still there means that A will also start playing a role, because even if you know C, you can think of this in multiple ways. Like C is fixed. Let's say C is a binary variable, it just takes the value of 0, right?
Yes.
This 0 value can come with multiple configurations of A and B. Okay, I mean, this is just an analogy that you can think of this particular thing in this way, that A and B can lead to the same value of C with multiple configurations, right?
Yes.
So once that is the case, then A and B both, I mean, if C and B were both given to you, then you could have said that A is fixed, because you have fixed this, you have fixed this, you have fixed this, that means this is also fixed.
Right.
So then you could have said that D was independent of A, but since B is not given here, A, it cannot be independent of A.
Thank you very much. Thank you.
Yeah. Okay, any more questions?
Sorry to bother you, but
Yeah.
can you please explain this Markov blanket in random fields, the variables which come under Markov blanket?
Markov blanket, I think he just introduced and did not, I don't think you need to know Markov blanket as of now. I mean, that won't be required for
It is
this.
required.
It
It
is,
is required.
it is required where? In this course, in this assignment, is it?
In this assignment, but actually that concept is used in the next assignment. It is not that bit clear, so that's why I'm asking.
Actually, Markov is Markov blanket. I also looked at the lecture, but the professor himself said that it is not that much required. So I did not play much. So if you give me the time, maybe next week I will talk about Markov blanket. I'm not. I also have not. I'm not sure about what it is, because it was not taught that much in the class, I guess. Okay, any more questions? Hello, I am audible, right? Hello. Hello. Am I audible? Oh, why is this not coming? Hello. I'll rejoin the call, maybe that will help. Hello. Am I audible now? I can't hear any of you, that's the issue. Okay, so I guess there is some issue. Internet connection is working fine. So any questions you can paste in the chat box maybe. Any questions you can paste in the chat box. Okay, if there are no more questions, maybe I'll can't hear anybody speak anything. Okay, maybe I'll end the call because I'm not able to. There is some issue with my system, maybe, I don't know. So thank you. Next Saturday we'll meet again. I don't know whether